Hey everybody, I'm Raymond, and today we're talking about version control, Git, and GitHub visualized and explained. Feel free to skip around to the parts that are new to you, or whatever you need to refresh on at the moment. So when I first decided to start making videos about computer science, I wanted to pick something that's often glossed over in school, but it's pretty important. Version control is definitely one of those things. Even if you're a coding master that can make anything, if you accidentally erase all of your teammates' work because of a wonky Git command, you won't be fun to work with. First, we'll explain what problem version control solves, then we'll explain what version control is and why it's important. Finally, we'll talk about how version control is structured. In future videos, we'll walk through a typical use case and the most common commands, and we'll go over some advanced scenarios. Most software is made with teams, but the finished result is a single collection of digital files and folders. Since making software requires multiple people working on a single group of files, coordinating how programmers work together is important to ensure that they can get work done quickly and efficiently. So our objective is to allow teammates to contribute to the project as efficiently as possible. Good examples of collaborative software are Google Docs and VS Code LiveShare. They allow multiple people to work on a document at the same time. Would Google Docs and LiveShare work with writing software? Absolutely not. First, we can easily eliminate Google Docs because it doesn't have any software development tools. But VS Code LiveShare is also a poor choice. It's very difficult and inconvenient making new software while someone else is editing the files in the same folder. If you wanted to run your code to test your progress so far, you'd have to ask your teammates to delete or comment out their unfinished work so the app could compile. This would constantly slow everyone down. So let's refine our objective. We need a way to allow each of us to work on the same project efficiently without interfering with our teammates' progress. This will allow me to do everything I need to do and run the code as much as I'd like without slowing anyone down. The solution is to make different copies or versions of the same code base. Each version represents a change to the code base. A version will release to the public, a version for testing, a version for the current thing you're working on, etc. This way I can work on my own version and run or test my code whenever I want without interrupting my teammates' work. Lastly, we need something that can manage or control all of these versions in a way that makes it easier for us to keep track of them all. We want to focus on what needs to be made now, not on what has already been built and tested. For example, we can make sure that the version I'm using to add new features already has all of the previous things we've built and tested included. This way, I can make sure what I've added works well with what's already been built. The answer to our problem is a version control system, or a source control system. These systems do everything above and help teammates make software and manage the changes they make to their products. Git is a version control system, and GitHub allows you to upload your version controlled projects online so that anyone can contribute to them. Okay, so what's the best way to manage all of these changes we want to make to our code base? First, let's define a change a little more clearly. We don't want to literally make another copy of our code base every time you add a single character. That would create a massive group of versions, most of which would be useless, because the changes wouldn't be significant and it wouldn't compile. By change, we mean a significant change, like fixing a bug or adding a new feature. These individual edits needed to make a significant change are grouped together into a single significant change called a commit in the version control system Git. These commits are the significant changes that make up the versions we'll use. For example, if, in order to fix a bug, I needed to create 2 new files, edit 5 lines of code in an existing file, and delete a file, this will all count as one significant change, and will create a single commit containing all of the changes associated with that change. By creating this commit, we've created a new version of the code base, one that includes the new commit. Now, how do we manage these commits? Well, if you think about it, our first version is the first commit we make, then we add something, we make another version, and then we repeat until we're done. Basically, when you're done, you'll have a large list of versions that are all made up of the commits we've made in chronological order, showing each task completed. In other words, the finished version control system will have a group of commits that are a timeline of our code. from the first key press to the final feature added. You'll be able to visit previous versions of your project since each version is a collection of one or more commits. So, the best way to organize these versions is chronologically, from earliest to latest. By building and thoroughly testing each change before progressing, it allows us to focus on the latest change, giving us less to worry about. Since we're a team, new commits won't be created one at a time. Usually new commits will be created at the same time, since each teammate will be working on their own bugs or features. So the last thing we need is a way for us to create versions of the code base that have unique commits in them, separate from the main group of commits. This allows us to store commits in a different location, outside of the original collection of commits, in case we don't want them included in the final version of the code base. We do this with branches. A branch is a group of commits. All branches start from the first commit, but they often include commits that other branches don't have. If you think about our timeline analogy before, you can think of branches as an alternate timeline. It contains some of the events or commits of the other branch, but then has commits that only exist in that branch. You can create any branch for any purpose. Just remember that the branch you make includes the commits in that branch, as well as the commits from the branch you created it from, often called the base branch. Commits created in the base branch after you make your new branch are not included. For example, a common practice is creating a development branch. After initializing version control, a master branch is made by default, which typically only contains commits that will be released to the public. So by creating a development branch, you create a place where you can add or remove commits without touching the master branch. Lastly, adding commits from one branch to another is called merging. A typical workflow is to create a branch for the feature you're adding or the bug you're going to fix. Merge that branch into the develop branch when ready, test that the new develop branch works as expected, then add the new commits in the develop branch into the master branch through a merge. Now you have a version ready to release to the public. In the next video, we'll walk through a typical use case for version control, then we'll explain some special situations that require advanced Git commands. This is my first YouTube video. If you enjoyed it, please hit the like button, subscribe to the channel, and hit the bell icon to get notified when the next video hits. Feel free to leave a comment or any feedback you have. Thanks and see you soon.